Hello friends, here in this video we are going to see a problem on projection of solids for a square prism. Here is the question. A square prism with side of base 40 mm and axis height 60 mm is resting on the HP on one of its base corners such that its axis is inclined at 30 degree to HP and parallel to VP. Draw its projections. Now, by reading the question, first thing I have understood is the type of solid. It is a square prism. So first I'll just draw a rough diagram of a square prism. Now, this is a square prism and it is resting on the ground. On the ground is also called as on HP, because in case of drawing we have two planes, horizontal plane and vertical plane. Vertical plane called as VP, horizontal plane called as HP. Whenever it is mentioned in the question that a solid is resting on the ground, it means it is in HP, or they will directly tell that it is in HP, like in this problem, that a square prism with side of base 40 mm and axis height 60 mm is resting on HP, but the condition is on one of its base corners. Now, when I look into this condition, in case of solids, the first thing is we should be knowing that which condition to use, because if we look at square prism, there are edges, 4 edges, at the same time there are 4 corners. We should be very much clear which condition to use. Next, whatever kind of solid is there, we would be tilting that solid onto the right hand side. So if a square prism is resting on the HP or on the ground, then when I am looking from the top, that is from the top view, from top it will appear as a square to me. So I'll draw that square and check which condition is correct. When I'm looking from the top, now the square prism can look like this, but when I will be tilting it onto the right hand side, it will tilt about this edge, and in the question it is mentioned that it is resting on the HP on one of its base corners. So here when I am drawing a square in this way, it means it is incorrect, because when I will be tilting it onto the right hand side, it will tilt about the edge and not about the corner. So it means I have to draw this square in some other form. And what is that? Now, square can be drawn into two different ways, either resting on the edge or corner. In this question it is mentioned that it is resting on the corner, and when I tilt it onto the right hand side, it will be tilting about this corner. It means out of the two conditions, this condition is correct and we have to follow this. Now, how to draw this square? This square, which is the square prism and looking like a square from the top view, since it has this angle as 90 between the edges, or we can say between the rectangular faces, so the remaining angles are 45 degree on each side. So it means here the square has been tilted at 45 degree, and I have to use this condition as the initial condition, and next I have to make the axis inclined at 30 degree to HP. So before going on to that part, first I'll draw this initial condition. Let us get started with the solution part. So this is the XY line, and here we have VP vertical plane, HP horizontal plane. Next, the square prism is resting in HP. I have explained the initial condition, which is it is inclined at 45 degrees. So I'll start with that. Whenever I'm using green color here, green indicates light line, or we can say the projection lines. Measuring 45 degree on both the sides, because the square edge which we are drawing, that is inclined, square prism is resting on its corner. Then I'll draw a light line from here. Similarly, a light line from here. The square prism is having 40 mm side, so I'll mark 40 over one of the edges. Next, I'll measure the distance in the compass. Mm. Similarly, here also I'll mark 40. Then, keeping the same distance, going to draw an arc here. Next, from the other side or the other corner, I'll cut this arc. So here I am getting the intersection point. I'll join this to complete the square prism. Now, after drawing this square prism, as I have told, when I am using green, that indicates light line. So for the initial condition, I'll have to make it dark. Now, here I have drawn the square prism, how it looks from the top, light. Next, I'll make it dark. So drawing the edges dark. So a square prism, when it looks from the top, it will be a square, and here we don't have to connect the edges because it is not a pyramid. In case of pyramid, we would have been connected these corners as well. Now I'll give it the notations. This will be 1, 2, 3 and 4. Then here is the prism which looks from top. Next, I'll draw the front view for this, and in the front view it will appear as a rectangle. So projecting those points first. Now the axis height given in the problem is having axis height 60 mm. So I'll mark 60 over this. So once I have drawn it light, next I can make the edges dark. Writing the same notations in the front view. So this point 1 in the front view, I'll write it 1 dash. So even there is a square at the top, again 1 dash. Next 2 and 4, they are coinciding. So we have 2 dash, 4 dash. Similarly 2 dash, 4 dash. Here we have point 3. So it is 3 dash, 3 dash. At the bottom, at the top. And here in case of square prism, I am getting two rectangles. In between them there is a dark line. It means these two rectangular faces are not on the same plane. That is indicated with the help of this dark line, because whenever we have dark line in the drawing, it means change of plane. So here, as we can see in the top view, 1 to 2 this rectangular face, 2 to 3 the other rectangular face, they are on different planes. So it is indicated on the front view with the help of a dark line in between. Next, if we see the axis for this square prism in the top view, in the top view we cannot see height. So here, while connecting the corners and making the diagonals, joining the diagonals at the intersection, I would be getting the axis for this square prism, which I can give it as point O. But if I see here, the axis and even corners 2 and 4, they are passing through the same line. It means axis and the other two corners which are making the edges, that is edge 2, 2 dash, 2 dash and edge 4 dash, 4 dash, they are coinciding with the axis. So even the axis is on this dark line. Next, this is the initial condition. After that, it was given that the square prism is resting on the HP on one of its base corners. So that base corner is corner 3, which is indicated with the help of 3 dash, 3 dash, which is an edge here. Next, such that its axis is inclined at 30 degree to HP. Now we must be very clear that if the inclination is given with respect to HP, it will be seen in VP, and if it is opposite, that is the inclination is given with respect to VP, it will be seen in the opposite plane, that is HP. Here it is given that it is inclined at 30 degree to HP. So it means it will be seen in VP, that is in the front view. So now this axis needs to be tilted at 30 degree. In other words, I can say that here I am having the axis which is coinciding with this edge at the middle, and here there is the base. So axis and the base, they are perpendicular to each other. So when I would be tilting the axis at 30 degree, it means the base will be tilted at 60 degree. So I'll draw it in this way. So here I am drawing the base inclined at 60 degree. drawing a light line first. Next, I'll take the base from 3 dash to 1 dash, taking this distance, keeping the point here and marking over this inclined line. Next, I'll take the half of this, that is the distance from 3 dash to 2 dash or 4 dash, they are on the same line. Next, after plotting this, I'll draw a 90-degree line, because here the base is perpendicular to the axis. So projecting the light lines, and next I'll be marking the height, which is the height of the axis, and it is same as the entire height of the prism, which is 60 mm. So keeping this distance and marking it onto here. Joining them first with a light line. So here is the prism which I have tilted. Next, I'll make the edges dark. Now, I'll make the edges dark for this square prism which is inclined. Then I'll mark the notations over it. The corner on which it is tilted, that is corner 3 dash. And here I can say that the axis is over here. Inclined at 30 degree as given in the problem, and it is 30 degree with respect to HP, but it will be seen in VP. Now, once I have drawn the front view, then as per the visibility I have to draw the top view for this tilted square prism. In case of drawing the top view, my direction is here, that is I am looking at the prism from the top. So when I am looking the prism from the top, it has two square faces. One is at the top and other is at the bottom. So out of that, the square face which is closer to me, that is closer to the observer, will be drawn first. If I see here, the square face which is 1 dash, 2 dash, 3 dash and 4 dash, this face is closer to the observer as compared to the bottom face. So first I will be drawing the projections for this square face. Let us get started. Here, starting with point 1 and 3, they are onto the same line in the top view. So this will be projected first. Next, in drawing, the sequence is quite important. We need to mark one point at a time. We won't be taking the projections continuously of all the points and marking the projections together. We'll take one projection at a time and mark it, because sequence is quite important. So here, First is point 1 dash. Now in the top view, here I'll be getting point 1. Next, point second. For that, I'll take the projection from the top view, that is point 2, which is there in the top view in the initial condition. Next, point 2 will be projected from the front view. So as per sequence, here there is the second point. Next, point 3 dash. So here there is point 3. Next, for point 4, I'll take the projection from the top view. And here the projection is there from the front view. So this is point 4. Next, after drawing the projections for the square face which is at the top, now for the square face which is at the bottom. So first, starting with 1 dash. Point 1. Next, 2 dash and 4 dash. So here they are onto the same line. Here we are getting point second and point fourth. At last there is point 3 dash. Point 3. Now, once I have marked all the points, based on the visibility we have to connect the points. When I am looking from top, this complete square face is visible. It means these points 1, 2, 3 and 4 will be joined with the help of a dark line. So from 1 to 2, then 2 to 3, next 3 to 4, and 4 to 1 is a complete square face. Then here, in case of projection of solids, the outer edges are never hidden. It means we have to always make the outline dark. So if I see here, this point 4 and 4, which is an edge, will be connected with the help of a dark line. Then edge, which is 2 2, will be connected with the help of a dark line. Next, 1 to 2 and 1 to 4 will also be connected with the help of a dark line because it is an outline. One to 2 and 1 to 4. Now, once I have drawn the outline for this square prism, next I will have to check from the visibility point of view which of the edge is visible. So when I am looking from the top, the closest edge is 1 dash 1 dash which will be visible. So I'll have to connect 1 and 1 with the help of a dark line as it is visible from top. Next, as the square prism has all the edges which are continuous, so even 3 and 3 will be connected. But if I see here, observer is at the top, edge 3 dash is at the bottom. It means that edge won't be visible to the observer, so it should be hidden. So connecting 3 and 3 with the help of a hidden line, which is a dashed line. Now this is the projection of the square prism, and finally here I'll give the dimensions. The base edges were given as 40, mm, and axis is inclined at 30 degree. So this is the solution to the problem, in which they had given a square prism resting on one of its corners, and then that square prism was tilted in such a way that the axis is inclined at 30 degree, and we have drawn the projections. At the same time, here I can see that since square prism is made up of continuous edges, even 3 to 4 and 2 to 3 should be joined, but as they are at the bottom, so that would be hidden. So drawing the hidden line here as well, connecting 3 to 4 and 2 to 3. So this is the complete solution to the given problem, and with this we complete the question.